Hello, everyone. Welcome to the second episode of writing our own in memory key value database in C. So, in the previous episode, we tried to write a hash function. We didn't write it actually, we just copied it from a sample on the internet. And then we talked about the hashing functions concept. We talked about the hash tables. We talked about the collision. So, if you have not watched it yet, you can just watch the previous one because that's kind of background for this one. And in this session, we're going to try to implement a hash table in C in practice, an actual one I'm in. But right before we get into the point of the implementation, I have to explain some stuff regarding the hashing functions. As I told you in the previous one, in the previous episode, you can actually write your own hashing function, but probably that's not going to be a good one, not a let's say advanced one, because the distribution is really important. By distribution, I mean you have to clearly have a way to distribute the results that you're generating while hashing, that you actually cover all of the numbers when it comes to the hash tables indexes, right? And it's really hard to actually guess or write that kind of function yourself. So, and also, given that this collision challenge is always there, and we said that we're going to use double hashing as the solution for the collision challenge, now I want to introduce you two very famous hashing functions. The first one is called DJB2, and the second one is SDBM. These are pretty much known hashing functions that you can just copy and paste and use them straightforward. And you shouldn't really write your own hashing function, even though you can, but that's not going to be really efficient in terms of the coverages on the indexes of your table. So let's just pick these two. We have just our project left from the point that we had just this DJB2's hashing function. We just copied it last time, if I'm not mistaken. Yeah, exactly. But and that's called DJB2. But I'm going to just copy the second one and add it as the second hashing function, because we're gonna double hash our keys in order to overcome the or solve the challenge of collisions. I'm going to copy it right here. It's written in a very traditional way of writing C functions. I forgot what is the name of it, but this is not anymore how we actually define our functions. It should be really simple like this. And for me, it should be constant character pointer of character, because these strings are defined like that. Sorry, it should be str actually. And then, what is this warning? Using the result of assignment as a condition. Okay, I think we can just simply put it in parentheses, and that should be solved. Exactly. I am going to rename this to hash1 and the second one to hash2, so I can just use them quickly instead of guessing or remembering the actual names of them. How can I format this? Okay, cool. Now I have to add the second one to our header as well, because we're going to use them. I'm going to include them in other files, in other C files. And let's just try if they work actually. So hash1 should work, and unsigned long index 2 hash2 should be like name. And then let me comment this out, because we're gonna have some warnings. I don't want warnings. And print out index 2 to see if that works. Make, and that works. That's good. Let's do make f clean to have a clean project. And there we go. Let's implement the um, hash table itself. So I have to do some scaffolding and like file structure designing in our project. I'm not going to take it serious right now because over time, eventually, this is how I do in real project. You just get more mature in terms of how you structure your files as your project grows. So it's not really how much you can predict or how you pre-design it, but it's the matter of how you reorder them and customize them over time when you have more concepts and domains in your project. So I don't actually care about how I structure it right now because this project is gonna grow anyways, and at some point I have to change some stuff. So I am going to create a new folder called HT, which stands for hash table, let's say. And then I'm going to have ht.c file, which there I will store my functionalities for the hashing for hash table, let's say. True. So let's start with the hash table itself. As you may know, these hash table, also explained in the first episode, will have something like entries of key value pairs. So I'm going to start with that one. I'm going to be like type def struct, and there I'm going to call the name of this entry probably, or slot, whatever you prefer. I'm going to go with entry, and then I'm going to have character key, and then I'm going to have character value, and here it comes the first challenge. We have to design our database in a way that we can store actually Boolean and integer and long variable types. It shouldn't be actually always a string. So that's something that we have to really consider as an enhancement later. So it shouldn't be only strings, but all types should be supported. I'm going to take a look at it later. There we go. But also I was thinking about like a way that I know if that entry is actually occupied or is an empty slot. So probably I'll need something like a type def as well here, which is going to be an enum, and there I'm going to call it entry state. Yeah. And I'm going to start with occupied, and the second one should be empty. Yeah, let's continue with this for now. And entry state state. That's it for now. And now I have to really initialize my table, which is going to be like entry or entry hash table, and there I have to actually say how big should be my table. Okay, let's talk about the second challenge actually. So first of all, we have to really define how big our table is as the initialized version of the table, right? So I should be able to say if my table is 8 long, like it has 8 slots, 1, 2, 3, 4, 5, 6, 7, and 8. So each of these entries are the entries that we can store key value pairs. And as a initialized kind of number, like an init number, we have to say how long our table is. So I'm going to write down 32 for now. Let's make it a like define table size 32. Let's use that instead. Table size. But the challenge is that I am not aware of how many, let's say, key and values are going to be stored in the database during our program's execution, because user can simply save hundreds, thousands, and millions of keys, but I cannot start with a high number because allocating lots of space in terms of memory to my program without reason doesn't really make sense. And also, starting with something like 8 also doesn't make sense, because then the user cannot add the ninth, let's say, key and value. That's a limitation. So here it comes the concept of resizing our table. So we have to somehow think about a mechanism that can resize, extend our table. And I think also we should think about shrinking as well. Like why we should really have a table of size 100 when only 8 slots are used. So we can just shrink it down to make it optimized, right? But those mechanisms are going to be really difficult in terms of designing and thinking right now. So let's just keep it for the next episode so I can think about it and then implement it. Probably it can be an enhancement kind of thing. Let's add that as a to do as well. So to do implement resizing table size based on the occupied entries. Let's do that in the next episode. But for now, I'm going to start with 32. Actually, I'm going to go with 8 to see how the overflowing is going to work. How the overflowing is not going to work, actually. How the error is going to be. And let's now think about the insertion function. So let's go with I'm gonna go with integer type for my function. I'm gonna call it insert, and then I'm going to get a key like this, and also I'm gonna get a value like this, and there I'm gonna do some stuff, right? So when inserting, I have to find out where can I insert my key based on the hashing functions that I have, right? Let me think about it. So as I said, we have to really double hash our our keys, right? Yeah, let's actually do that. So I'm gonna be like, on. Should I import those hashing functions here first? Probably yes. So include, go one up, and then hash. No, sorry, utils. And there we have hash.h. That's good. Unsigned long. H1 is hash1. Key. That should work. Unsigned. Typo. And unsigned long h2, which is the second hash of our hash2's result. Again, I'm gonna hash the key. And now, okay, here it comes the probing. So there's this concept called probing, which stands for a way to find the closest empty slot in our table. And if we cannot find an empty one, so if in the first iteration we find out it is occupied, the probing equation or the function should help us to find the second actually empty slot. But that is something like a function, so you can actually reuse it to find the next available one when inserting and to find the next available one actually in searching. So it is a guessable kind of written on a stone kind of thing, so it's not a random kind of thing. I'm going to explain it more. And the way I'm going to do that, I'm going to keep track of something called index, right? And in index, I will have h1 mod table size. The reason I'm doing this is that, as I showed to you, the numbers, the hash numbers, the result of the hashing functions are long numbers. And it doesn't really make sense for a 32 slot kind of table. This is not a valid index, right? It is overflowed, it is outside of the bounds and range of that table. So I am using mod in order to limit that index to be inside that table, to be started from 0 to 32. That's how you do it in the programming, right? You just mod it with the table size. So that's the reason I'm doing that. And I'm going to have something as a second variable called step, which is going to be integer as well. And I'm going to do the same on that one as well. So I make sure it is still in the table range. But this can be a floating number, so I have to convert it to int probably, because index 1.2 doesn't make sense in programming, right? Cool. And now I have to do the probing. Let me explain more about probing actually. So there are multiple ways of doing probing. Let's first read about probing. Geeks for geeks probing in hash table. Okay, the first solution, the first way of doing probing is called linear probing, which is not optimized, because linear probing means after you just face an occupied slot or an entry, just plus by 1 the index and then check the second one and then the third one and the fourth one. And in the worst case, you have to search or go over n entries. So the time complexity of that is going to be big O of n. That doesn't make sense to use in a system like database, right? So linear probing is not a good way of writing a database or even writing a hash table anyways, because hash tables are meant for storing, inserting and searching for keys in a quick way, as discussed in the previous session. So let's not go with the linear ones. I think there should be something like quadratic probing. Yeah, exactly. Which is not linear, but still it's not efficient in terms of time complexity, because again you have to go over your, let's say, checked occupied slots to find out what is the next empty one, the closest next one. So it is really hard to explain it, but it is not efficient either. But the point is, if you use something like a double hashing and create a function that generates the next closest one based on something called index and step, that's going to be really efficient, because let me write actually how the probing looks like, and then maybe you will understand what I mean. It's really hard to explain. So I'm going to have a for function because I have to iterate, like I have to try different probs in order to see if I can find the next empty one. So I'm going to start from I, and until and while the I is less than table size, I would say, I'll increment I by 1 like this. And then I will create a prob index here. I explain what is probing, right? And there I will be like index plus I times step. And I have to still mod by. Do I have to? Yeah, I have to mod it by table size still to keep it in the range of the table. So this is what I mean by probing. I created a function or an equation that finds the possible next empty spots in our table. And this is written on stone, and I can reuse it. So if I've inserted something based on this probbing, I can search for the same key based on this probbing as well. So that's how I use this probbing mechanism. And I would go with, now I have an entry probably, which is going to be E equals, I'm going to, the HT, I'm going to just access the prob index of that table. And then I'm going to be like, if the E's state is occupied, or let's say empty or occupied. I'm going to check the occupied ones. If it is occupied, I'm going to continue. And continue will increment the I by 1, so it's going to be 1, so it's going to start from the beginning of the 4. That's what I mean by continuing. And if the E's state actually is empty, I will be like, add my key there. But here I cannot say key like this, because I have to actually str duplicate the key. So the reason is very obvious. If you're interested, you can just check what is strdup. But the whole point is that you cannot really, you have to duplicate the string based on the pointer for such a process. And I'm going to do the value as same, str duplicate key. This should be updated later, because not only string type values are going to be stored in the database, it can be an integer. So this is not going to be valid in the next episodes, but we're just doing a POC kind of thing for now. And then I have to say the state should be occupied, right? And right after that, I have to return 1, means I saved something, right? And if I was not able to save something, which means that I went over all the possible empty slots. I mean, not empty. I went over all of these slots and I couldn't find an empty one. I'll return 0. So my insertion was not actually successful. I'm going to write the second one, which is going to be character search. And there I'm going to look for const character, I can't type today, key. And I'm going to do the same probably. I have to really do the same thing. So copying and pasting. We're going to talk about the clean code later. So we are going to create reusable functions in order to not to duplicate these kind of sections. But now we're just making a POC kind of thing. And I'm going to have the same for loop actually. True. And but this time, because I'm searching, I'm going to be like, if I find E is occupied, and actually I have to check if it is the same key that I'm searching for, because you know what is the point? At some point, it is possible that the first prob index was not empty, so you had to go to the second prob index, and there you have saved your key, right? And here, when searching, you don't know actually if the first one or the second one is the key that you're looking for, so you have to really check if the keys also match. So I'm going to be like E. Oh, by the way, I have to use a function called strcmp. Exactly. What happened? And yes, I there have to check the key with the key. And the weird part is that strCompare returns 0 if two strings as arguments match. It is weird because as programmers we like think about 0 as a false and 1 as true in C programming language, but here is the other way around. I'm not sure what was the reason behind it for that design decision, but you have to check if it is 0 actually, not 1. So if it is 1, it means that they don't match. So if it is occupied 1 and if the keys match, I can simply return is value. That's simple. And what else? I just check if the occupied one and the keys are the same. I just return that one. And should I do anything else maybe? No, actually. Nope. That's it. But just in case, if you cannot find any kind of matching key, then you have to return null anyways, because you couldn't find any. Let's add these to the header file. We don't have a header file yet. We have to create it, HDH. And it should be, if not defined, HDH, then define HDH, and then end if. And there, here it goes. Why it's like this? What is the error? Define. I have to write down define. Actually, not an abbreviation. Define. And we have the search there. The other one is also really simple. Should I copy it instead of writing down everything? Yep. I'm gonna pick this one and add it here. What happened? Cool. I have my HD header files as well, but I have to add those here as well. So I have to say wildcard. I'm not even sure if this is a correct way of doing it, but I'm just doing it for now because for me it doesn't really matter. Later we can optimize and enhance all of these. So once I do that, I want to use them here. So I am no longer requiring anything from hash headers or hash from the utils actually, but I'm also interested in HD headers. And let's say I have something like a key called name, and then I have this value which is emot, and then I want to actually insert key and then insert value there, and I have to like say int result equals this. If result is not there, I have to use a semicolon. If result is not there, just print f there is an error while inserting the key, and return. What's wrong with this? Return 1, let's say. Return 0 still. This is not a error kind of thing. We're just doing some loggings. And I have to be able to do character found value equals search, and I'm going to look for key there. And if found value is actually null, then I'm going to be like printf no values found, or no entry found maybe. I'm not even sure if this is a correct way of printing stuff, because there might be another function instead of printf, because we're not formatting anything while we're printing. So, but this is not important. at this point for me. And if there is something, I'm gonna be like value is percentage as found value. That should work. And let's just run our project and see if that works. I have some errors. So it says unused parameter character. We don't use value anywhere. No. Wait, what am I missing here? Oh, I'm also storing the value. I'm storing key as value by mistake, so I have to do value. That was a big mistake actually. Make re. Cool. There's an error wall inserting the key. I don't know why. Let's take a look at it. So why we are having errors when inserting a key. So let's go to the insert. If I found a way to insert something there, it should be 1 and then it's weird. It's really weird. Let me just check the way I'm doing it. I'm storing key and value. If the result is not there, what happens if I just... Let me try it. I have some doubts on something. Okay, it says that what happens to the result, but I don't even care about result anymore. What happened? Make re. Okay. Let's find out. It's a good point to debug some stuff. I like it. Let's go and try to find the part that we are having that issue. That little bug that causes the error. So let's just put some printfs. That's how I do it. I mean, most of the cases. I'll be like h1. So s or no, lu, h1. We have it there, and h2 is lu again, h2. That's fine. And here again, we're gonna have d. Actually, for this one, we're gonna have d. But this is not h1 anymore. This is index. The other one is step. And I'm storing index. Not storing, printing index and step. Let's see if that works for now. Actually. And make re main. And I see like h1 is there, h2 is there, index is 6, step is 3. Okay, so up until that point, everything seems working. But then we have this index plus I times step table. So yeah, that should be fine. And then I check if it is occupied. I just continue in the for loop. If it is empty, actually, I just I duplicate the key, put it in the key there. Nope, actually. I have to... What is the point? Should I use the... No, I shouldn't dereference it. What is the point? I'll ask anyways, ChatGPT. That's how I do it. Can you find the bug for me here? causing an infinite loop. You have this because HT is a global array. It has static storage duration. All bytes are 0 initialized. That means for every entry in HT, key is null, value is null, state is 0, but in your enum, occupied is 0 and empty is 1. So at the startup, every slot is marked as occupied even though they are actually empty. Oh, damn it. Okay. So probably switching the order of these should fix my... Is that correct? Don't tell me that's correct. Okay. Okay, yeah. I could have spent a night, full night on it. So when we say empty is the first enum in this enumeration, it has a default value of 0. Oh, shit. And because this is a global kind of state on my application, I'm in the hash table. By default, all of these states are going to have 0 value, and 0 means empty. But in the previous version that occupied was before empty, occupied was 0. So actually, we didn't have any free slots in our table. That was a good one to just learn about it. What happens if I say occupied is 1? Does that work? Empty is this a correct syntax even? I'm not sure. Make re. That compiles and that works. Okay. That's the whole point. That was the whole point. I'm very glad that we implemented a hash table together, a very simple one. In the next episode, I guess we have to work on a way that we can write a interactive shell kind of thing so we can actually accept commands from user in terms of adding something and reading something. Probably I have to add the deletion functionality as well, which is a easy one. It's just freeing up that specific entry or reverting back everything to null and empty state. But we have to think about that. When the resizing and shrinking comes to the scope, then we have to really free that memory in the memory. And also we have to memory allocate in a lot of scenarios, I think. So let's write a interactive shell next time in the next episode. But for now, we understand how the hash tables work. We use the actual famous 2 hashing functions, and that was quite well. So let's see and meet each other in the next episode. Thank you very much.